In the in the last session, we talked about functions. We talked about function object. We talked about function literals. Using all these things, we defined higher order functions. Higher order functions. So higher order functions, we said that a function that takes one more function as a parameter, or a function that returns one more function from its body. So that's what we call as a higher order function. So higher order functions are, we saw the use case also, I mean to say, it drastically reduces the number of lines of code, and we can achieve lot of things with just few lines of code. So that's the idea behind the higher order functions. And we saw higher order functions with type parameters. To make it more generic, we use the type parameters. And higher order functions, I said that we may not write our own higher order function. It will be a bit rare, but there will be, I mean to say, not every time we will write a higher order function. Most of the time we try to use the higher order function which is already written in Scala and Spark. So we just tend to, we'll see such kind of a higher order functions which are already available in Scala and which we will be using more and more in Spark. Those few higher order functions we will be starting. Yes, the recording is going on. Yes, Rashika. So today we will be learning about collections. I think most of the people already know as collections. Here also there are collections because every programming language usually has a collection. So and I said that collections are immutable by default. I said that collections are immutable by default. So today we'll be learning about the collections here. So there are different types of collections. What I mean here is, yeah, good morning, Jairam. So collection is in this fashion. Always the main class is the traversable class. Then we have iterable class. Sequence, sets, and map are the main high level collection types. Sequence is a collection actually. Set is also a collection. Map is also a collection. Map is just like our hash map in Java or dictionary in Python. Sets again is a unique collections. Sequences are normal collections. It could be a list collection or a vector collections, or we can say indexed sequence or a linear sequence. So again it will keep on adding more and more. Like we have hash set, inside the sequence, indexed sequence, there are many other things, vector, numeric range, all those stuffs. So we'll be seeing few of the collections here. and our main goal is to how higher order functions applies on the collections. How higher order functions applies on the collection. So when the way we can write a collection is, I can say val nums is equal to a list of, I can say 4, 5, 6. So this is how we define a collection. This is how we define a list. A list is internally represented as a list is internally represented as a single linked list. So we'll have in this fashion, and it will have a reference to the next memory segment, or sorry, memory cell, or whatever memory location we can say. We'll have a reference to the next memory. So this is how a list looks like. Yeah, here is a question. The question is, in the collection hierarchy it says sequence, but in the code is list. The reason is sequence is a parent class of a list. If you see sequence, underneath we have linear sequence. Underneath we have linear sequence. So underneath we have list sequence. So this is what I am creating. So list is a child of a sequence class, but under the category of linear sequence. So what do we mean by linear sequence here is, what do I mean by linear sequence is this. It is implemented in a linear fashion. It is implemented in a linear, sorry, we have to traverse the elements in a linear fashion. If you want to, let's say there are these many elements, right? If you want to access element 6, so you have to traverse from the first element to the third element. If I want to access 7, I have to traverse from the first element to the fourth element. So we have to traverse in a linear fashion. So that's why it comes under the linear sequence. So lists are under the linear sequence. So I hope that was clear, Rashid. And this is the syntax. This is the syntax as simple as it looks like. List keyword and parenthesis, and inside the parenthesis you give all the values. And also you can see that the data type is automatically inferred here. We don't have to anything explicitly. It says that it is a collection of integer. It is a list of integer. In a similar fashion, I can say a list of so this is a list of strings. So automatically the compiler has inferred it has a list of strings. So this is how you define a collections. And there are many methods. As I said, anything that you create in Scala is an object. Nums is an object of the type list of integer. Colors is an object of the type or of the class list of string. list of string. So any operations that you want to do on a collection, we can do it using the methods on that collection. We know that there is nothing like operators. It's all about the methods and objects because Scala is a pure object oriented program. So we can see what all methods that are available here. Nums, if you just press dot and press tab, dot and tab. So these are all the methods that are available in the collections. So there are a lot of methods. Even I haven't used all the methods in this collection. So we'll see few of the methods and how important they are. But this is how we see all the methods. So let's to get the first element of the collection. These are all simple things. So you can get the first element of the collection. Head is a method actually. Head is a method. Similarly, when I say tail, except the first element, it returns all the elements as one more collection. I can say val x is equal to something. So now x is a one more collection in which we only have we have all the elements except the first element. That's what the tail gives us. In a similar fashion, there is something called as last, which will give you the last element of the collection. In a similar fashion, I have init, which will give you the last all the elements except the last element. Except the last element. 4, 5, 6, 7 has been skipped here. So these are simple APIs that are available. If I want to access the element of the collection, we know that nums is a collection. So this is how you access. This is how you access. So we don't use square brackets. Usually in most of the programming language, you will see that square brackets are used to access an element of a collection. But here we use a parenthesis to access the elements of the collection. And also I said that internally, I mean, Scala is a pure object oriented program. So the way you access the element is also through a method. It is also through a method. There nothing exists like a index here. Internally what happens here is, internally it calls a apply method. There is a apply method defined inside the collection class, and it works in this fashion. Internally it calls the apply method. So the only property of apply method is it need not be called by its name. That's the meaning of apply method. So what I'm trying to say here is, it is just, there is no new concept associated with the apply method. It is just like any other method. Just to showcase that, I can define a class ABC. Inside that class, I can define a method called apply. And I can just multiply it by 2 here. So I can define one more one more method apply. As I said, it is just like any other method in the class. You can have a overloaded version of that method also. So I can have any number of apply methods, just a overloaded form. I can say x int y int, and I can say x star y. So this is just a apply method. There is no new concept I am saying. No new concept. It is just like any other method you define inside a class. The only property of this apply method is we need not call it by name. We need not call it by name. that simple property gives you lot of use cases. That simple property itself, you can have a lot of use cases. So let's redefine val abc. I will create an object of this class. I'll create an object of this class, and I can say abc dot. Usually we call the apply method in this fashion, and we pass some value. There is a method available which takes an integer. I'm calling that method and passing an integer. So the definition, the method gets executed. But I said that we can also, we need not call that apply method with the name. Only the parameter has to match. If it is 4, it will, the method which takes an integer as the input parameter, it will be called. In a similar fashion, I can call apply method with 4 comma 5, because there exists a apply method that takes two integers, but we know that we need not call it by name. We need not call it by name, just pass the parameters. It will check whether such a function exists in that class, then it will. So it's a simple a property that you need not call the name of the apply method. We can skip the calling of the apply method by its name. We just have to specify the parameters. If the parameters matches, then that corresponding apply method will be called. In a similar fashion, when I say zero, nums of 0, there exists an apply method in the collection class which takes an integer as a parameter, and it returns the element at that position. I can pass anything. I mean to say 3. If I pass, internally there will be an apply method that will be called. What will happen if there is a different method name with the same argument in the class? No, we can have different method name also, but those methods you have to call explicitly. You have to call explicitly. Any method you have to call explicitly. It's only the property of the apply method. So what I mean here is, I can define, anything. Oh, my mistake. I did not have a open. Something I will write. I will just say x int. I will say x plus 10, something. So you can always have any method with the same name, same number of parameters, but that will not be called because these methods we have to call explicitly. We have to call explicitly. So it will call, okay, 5 2s are 10, always the apply method will be called. Always this method will be called. So if you want to call the other method, we have to explicitly say this. We have to explicitly call this. That property does not hold good for other methods. It only holds good for apply method. So different, you can say that, Jairam is saying that it's like a get method. We can say that. I mean, it could be used for any purpose. It could be used for any purpose. We'll see more and more of a apply method. In case of a collection, it is used to access the elements of the collection. That's the use case. So this is one of the use case. It is used to access the elements of the collection. There are some other ways also we can access the elements of the collection. Sorry, there are other use cases also of apply method other than the accessing of the elements of the collection. It is just a method. It is a developer's responsibility how we can use it. How we can use it. Sometimes it is used to define uh, factory design pattern. We know there is a factory design pattern. Apply method can be used there with the for 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 developing a factory design pattern. We'll see that. We'll see that. So we can. So if you remember, we did something like this for. If you remember, we said we wrote a for expression something like this. So and also said that if you see the syntax, it's a simple syntax. It's very handy syntax. It's very easy to remember syntax. And I also said that on the right hand side of this, there has to be a iterator or a collection. It has to be an iterator because if you see iterable, it has to be an iterable on the right hand side. So meaning you can have any of the collections on the right hand side. In the for loop, you can have any of the collections on the right hand side. On the right hand side, it always has to be iterable. That's how the for expression is defined. So obviously this 1 to 7 has to be a collection, and it is a collection actually. So it is called as a range collection. To handle the numerical values, they have come up with the handy collection called as a range collection. So actually it is a collection in this fashion. It is called a range collection. So we know that there is no operators in Scala. No operators in Scala. Actually what is happening, we know the syntax, what the syntax means. On an integer class, there is a to method to which 7 is being passed as a parameter. So this is an integer, there is a to method, and it takes 7 because we have seen this. If you remember in the earlier sessions, either you can write in this fashion or you can write in this fashion. We get a collection. This is called as a range collection. So for all the numerical kind of looping things, we usually go with this syntax, which is actually a range. Which is actually a range. Similarly, we have also seen 1 until 7. 1 until 7. So in this case, we will be excluding the last element. Again, it is also a method on an integer class. Inside the integer class, there is an until method which takes 7 as a parameter and returns the result. We get a range. So this is also one kind of a range. You can see that, I think somewhere it will be here. Under sequence, numeric range is the one. This is that what we are talking about. It comes under the indexed sequence. It is not a linear sequence, it is an indexed sequence. We'll see what is the difference between linear sequence and the indexed sequence. I think we can also have we can also have in this fashion. Such kind of things can also be there. So these are all the collections. So keeping these things in mind, and also the for loop that we discussed, so usually we do in this fashion. There is a for expression and a collection here. We bring them together and we loop on that collection. So one more thing I forgot to say. We said val range is equal to 1 to 7. Then also we said by -2, if you remember, by 2 we remember. So actually by is a method on the collection. So this will return a collection, we know that. This will return a collection. This will return R is a collection now. On R, there is a by method. Which takes how much you want to skip. So when we are using inside the for expression, already we have got the collection. Then the looping will happen. So that's how the by we do. By is a method on that range collection. So when we do a for loop, when we are doing a for loop 1 to 7, by 2, when I say, actually the collection is already created and I will be looping on that collection. In a similar fashion, we can say 7 to 1 and by minus 1. So this way also it works, or by -2 will also give the one more collection. So this is what we used inside our for expression with objects as the here is a question. Does for loop will create two collections one by one? Collections 1 by 1 to 7 and another by increment by 2. Right. It does create a two collections actually. It does create a one more collection. The original collection will not be used. Internally it will create a one more collection. That's true. Because collections are, if you see, it is immutable by default. It is immutable by default. It will actually create one more collection. Internally This collection, when we say this, internally first this collection will be created. On that, apply method will be called, sorry, a buy method will be called, and it will return one more collection. So this will return a collection, then buy method will be called. Right, that's how the memory will be consumed. That's the until the scope, the memory will be consumed. After that, the memory will be given to the JVM. It will be given to the JVM. Till the scope of that collection, it will be available. But again, uh, that's one of the drawback of immutability. That's one of the drawback of the immutability. We will see how that is resolved when we use such collections in an application. Spark is one such application. We in Spark it handles uh, the way memory is not consumed much. We will see that. We will see that. But yes, there will be some memory extra when we do a collection. And any operation on a collection. Any operation on a collection.
Pramod, last week.
Yeah, Raj.
Yeah, is it a drawback of Scala?
No, no, it is not the drawback. No, no, it's not. I mean, when you say immutable, since it is mostly used for distributed purpose, distributed programming purpose, we don't usually say as a drawback, as a bit memory will be consumed. That's we can say. Not Scala, it is functional programming language. Because immutability means respect to functional programming language. So here this is one function. You can independently take this function and write it anywhere. So this whole thing could have been written in a for loop. But if you write it as a for loop, we lose functional programming style. This has been taken as one function. This has been taken as one more function. We can separately write this function and run it on anywhere. So we can chain multiple functions together. And one function can also independently run somewhere else also. But if you write the whole thing in a for loop, you cannot modularize it and run it different CPU cores. So that's the idea here. It's a drawback or limitation, or we can say, about the functional programming language, not the Scala. Immutability, because it is happening because of immutability. But we'll see in Spark
Uh, it,
how this is solved.
okay. Suppose if we use, I mean, like, multiple immutability collections in, I mean, like, while developing the application, it will cause any performance issues?
No, 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 nothing. Mainly we will use, we will also use normal mutable collections also. So what Scala is doing is, by default the collections are immutable, but there are mutable collections also. But we have to explicitly import them. We have to say import collections, like we saw this range, right? In a similar fashion, there is Scala collections mutable, and we have to say mutable collections dot collections dot mutable dot some array buffer is there. This is a mutable collections. We have to explicitly import this, so we don't get a mutable collections by default. That's what I meant here. It is a collections are immutable by default. Whenever you ask for a collection, you get an immutable collection. But we have to explicitly use a mutable collections. Whenever you want mutable, you have to explicitly ask for that. So we'll see when we are using a mutable collection, when we are using a immutable collection. We'll see that when we mostly do Spark, we'll see the difference. We are using, because that belongs, Spark is an application, we will be seeing there also. And sometimes we use mutable, but most of the distributed processing, it is a immutable collection, and most of the single hand processing we use a standalone processing, we use a mutable collections. We will see that. We'll see that. So this is what we were seeing. We are having a for loop. We have this collection and we loop through the collection and we get it. We have taken for expression and we have taken a collection and we have put it together and we got the result. The same thing can be achieved through a function or through a method on the collection. Through a method on a collection itself, we can achieve this for. So that method is, on nums is a collections, we know. On nums there is a for each method. On nums there is a for each method. So we'll discuss this for each method now, because these are all the important methods that we will be using in Spark also. So I will just generalize this concept. I will just generalize this. So we have a collection. Let's say we have a collection of type A. So if you see, the reason I am saying that is because nums is a collection of type integer. Colors is a type is a collection of type string. Means internally type parameters is used. Scala internally, the Scala compiler has defined a list collection of type parameters. List is of type parameters is used in the list. That's the reason we are able to define a collection of integer and also collection of strings or any other collection, because it is a type parameters. So keeping that in mind, I will just write it in generalized collection of type A. Here collection is nums of integer or could be colors of string. Colors of string. On that we are having a for each function. For each is a higher order function. In the last session we saw what is a higher order function. Higher order function is a function that takes one more function as a parameter. Here also the way it is defined is, for each function is a higher order function that takes a function. And it takes an element of the same type as the collection type. So we know that this syntax. We know this syntax. For each is a higher order function which takes a function. If you remember, we wrote our own higher order function which takes a function, and that function takes a string and returns a string. Here this function takes a element of the type or a parameter of the type A, and it returns unit. The return type unit means is a mutability function. We can this function has to modify something. The function that we pass to the for each is usually some modification function. It could be a function, it could be save to file function. It could be a write to DB function. It could be uh, write to message queue function. It could be update global state something. So it could be any function. So what we are trying to say here is, whenever you want to save the elements of the collection, if we want to save the of a collection elements of a collection to a file or to a database or to a message queue or to a global state, use for each higher order function and pass a corresponding function what type of operations you want to do. So that's the idea behind the for each higher order function. Or you want to print on console. Print on console. So we can use the print also, because print also takes an element and returns a unit. Returns a unit. We know that. And what is this A? What parameter is this A? So this is nothing but we pass each element of the collection to this function, meaning this function is called, whatever function we pass, that function is called for every element of the collection. Whatever function we pass as a parameter, that function is called for every element of a collection, and that every element of the collection is being passed as a parameter. So it is passed as a parameter. So that's the idea of the for each higher order function. Whenever you want to save the elements of the collection to a file or a database or write to a message queue or some global state, we use a for each higher order function. So we can write it here as well. Nums dot for each. Nums dot for each. It takes a one more function. It takes one more function here, and we know that that function has to take a element and return a unit. We know that println return type is unit, and it takes a single parameter also. It takes a single parameter also. So what happens here is, this function is called for every element. First 4 will be passed to the println. Next 5 will be passed to the println. Next 6 will be passed to the println. Next 7 will be passed to the println. The same for loop, the for expression, can be achieved through a function called for each higher order function. So I can write anything. I can define a function. I mean to say, I can define a function print. My own function, this is print, which takes integer, I will say, and I will say x is equal to x plus 5, then I will print it. Oh, it may give error because it's a val, right? I can define any function. val, I will say y is equal to x plus 5, then I will say println y. So if you see this function, my defined function, it takes an integer and it returns a unit. It takes an integer and returns a unit. And what we have, just a second. So if you see, this is also takes a, this function also takes a and returns unit. I mean to say, if I do it on a nums is a collection list of integer, and my print function, what it takes a integer and it returns a unit. Print takes an integer and returns a unit. The function that I need to pass also takes it matches, because our collection is of integer. So if you see, both are of the same type. Here is a collection is also integer, println also takes an integer. So it matches, and the return type is expected as a unit. Here also it is a unit. So obviously I can pass this function as a parameter to a for each higher order function. So I can pass, the idea here is I can pass any function. I can pass any function which matches the data type. This function will be called for every function. 4 plus 5 10, 5 plus 5 4 plus 5 9, 5 plus 5 10, 6 plus 5 11, 7 plus 5 12. For each element I am incrementing it by 1 and then I am printing it. So similarly you can write a save to a file method also. You can write a save to a file and we can pass that here. So whenever unit itself means it is a mutability function. Mutability function. So that's the use of a for each higher order functions. Whenever you want to save the data, use the for each higher order function. In a similar fashion, in a similar fashion, yeah, here is a question. User defined function use in the for each return type. Yes, any function that you write, it has to be a mutability function whose return type will be unit. Whose return type will be unit. Only such function we can pass. We cannot pass any other user defined function. We cannot pass. So I hope that was the question. We have to pass a user defined function whose return type should be unit. Only those functions can be passed to the for each higher order function. So in a similar fashion, if I generalize this collection, because I'm saying is a collection because this could be collection, could be list, it could be range, it could be array, it could be array buffer, it could be vector. If you remember, we also saw the vector. So this collection could be any of these collection. That's the reason I'm generalizing and just writing it as a collection. It could be list, it could be any, there, every collection has a for each higher order function. In a similar fashion, there is one more higher order function. So if you remember, we used for with yield. If you remember, we used for with yield. We said for I 1 to 7, 1 to 7, I said yield, then I said we returned a string interpolation, or a string we can say as day colon dollar I. So if you remember, we did a transformation. Each element of the collection was transformed to some other element in a collection. And I internally said that, internally this is implemented using a map function. So that map is nothing but a map higher order function. It is a map higher order function. So on a collection, there exists here also, when we say this is a collection, right? So instead of having a for loop, we are having a method which achieves the same thing. We have a method as a map. It takes a function of the type same as the collection type, because this function will be called for every element. So the element that we pass to this function, or the parameter that we pass to this function, comes from this collection. Hence the data type has to be same. If the collection is integer, a function should take an integer. If the collection is a string, the function should take input as a string. So that's the reason we are having the same data type. And now it returns B. It returns B. And also I forgot to write this. For each itself returns unit, and this returns collection of type B. So the idea here is we take one collection, and we return another collection of some type, That's what it is happening here also, right? In if you see the for loop, we know this is a collection. When I say 1 to 7, when I say 1 to 7, we know that it is a collection, and it is a collection of integers. This is a collection of integers. After that we transformed, and what we got? We got a collection of a string. So that's what that syntax also says. So if I say I will not write all the field 1, 2, 3, 4. So this is our collection whose type is integer, and we transform this into day 1, we transformed into day 2, we transformed into day 3, 4 has been transformed to day 4. So we transformed it into a collection of string. So I will say this is type A, this is type B. That's what we are trying to say here. Take a collection of some type. It could be an integer, and this function will be called on each element, and whatever logic you give inside that, it will transform that each element to some other element. It could be an integer also, or it could be anything else also. And once it transforms, the transformed element will be collected in a collection, and finally the whole collection will be returned in the similar fashion. So map is all about transformation. So instead of for and yield, I can write a function that does something. So I will define a function. Let's say I define a function saying which takes, I will say increment. I'll define a function say increment, and it takes an integer. And let's say I increment by 1 or increment by 2 something. No, map is a function. Right. Map, there in Java it is called as hash map. In Java it is called as hash map. I hope you are talking about the hash map. Hash map is a key value pair in Java.
Uh, yes, but in the Java, we're supposed to have key value pair, right? Uh, but in the Scala, it's the same thing, or again, it's a collection of objects.
No, I hope you are mentioning hash map, right?
Yeah, whatever it may be. Map is nothing but any map, like hash map, hash table, everything. The map
Right,
in general,
right.
you're talking about map.
Correct. Okay, yeah. So there it is a collection. In Java, map is a collection. In Scala, map is a function, method on a collection. It's a higher
Not
order,
a key value.
not a key value pair. But there is a key value pair actually. So small m map is a higher order function. There is one more map in Scala with capital M. With capital M, this is a key value collection, which is same as hash map hash map in Java. That's the so but map higher order function is a function on a higher order method on a collection, any collection. This on a any collection. So here is our idea. The idea is to transform anything that you want to transform each element of the collection to something else. So we use a map higher order functions. So what I want to do is I want to transform each element by adding 2 to that. So we can clearly see that it takes an integer and returns an integer. It takes an integer and returns an integer. So which matches this data type. So A is also integer in this case, B is also integer, but we can also have other data type also. So I can pass any function which takes some data type and returns some data type. Our increment is a function that takes some data type and returns some data type. In this case, obviously both are same. It is okay. So I can pass this function on nums dot map, and I can pass increment. The only criteria is this collection also has to be a collection of integers. I mean to say if at all nums is an integer, this function also should take an integer. Now this function is called for every element. 4, 5, 6, 7 we have. 4 will become 6, 5 will become 7, 6 will become 8. 2 is added and a new collection is returned. That's what I said in my code. It takes a collection and it returns a new collection based on this the same way. We saw this for yield. It takes a collection and returns one more collection of totally different. It could be of the same type, also it could be of the different type. So we need not define this function. While learning higher order function, we said that we need not define this function. We can directly use the literal of the function. We can directly use the literal of the function. I can directly use that. Only thing is I have to change it to a arrow mark. So it will give me the same result. And we also learned one more shortcut, that input parameter need not be specified. Input parameter need not be specified. It can be replaced by an underscore. It can be replaced by an underscore. So underscore is nothing but each element of the collection. It takes each element of the collection and transforms into a one more collection where 2 is added to every collection. 2 is added to every collection. So if you take MapReduce also, the same thing we do in MapReduce. I mean to say, the MapReduce framework, in the MapReduce framework there is a map function. It also does the same thing. It transforms each record to something else. It will read the data. From the data set it will read it. It will take each record. Each record is transformed to something else by the map function in the MapReduce framework. The same thing we are achieving at the language level by using the map higher order function. So we also have colors. So now I want the length of each string in the collection. I want one more collection which contains the length of each element of this collection. So how can I do that? So that can be achieved if you see that I can define a function and I can say get size. We know how to define a function which takes a string now. So I have to define a function whose input data type should be same as the collection data type. That's the criteria, right? That's the requirement. If it is type A, the function should also take type A. It should not take any other type, otherwise it will give an error. So that's the idea here. So S is a string, we know. S is a string. Obviously we can use string dot size. There is a method called size, or there is a method called length. Both will give you the size of the string. So you can call this function get size on Scala. Just simple string I will pass. Obviously it gives the size of the string. Now we can clearly see that it takes a string and it returns an integer. It takes a string and returns an integer. So that's what we are saying here. It can take any data type, I mean a data type that is same as the collection data type, but it can return any other data type. it can return any other type. In this get size, if you see get size, it takes a string, and returns an integer. And our colors is of the type string. Colors is of the type string. Collection of type A, the function takes type A. Collection is type string, the function takes type string. Here it is returning integer, hence B, as I said, it could be any other type also. It takes a string and returns it. So obviously get size can be passed as a parameter. Get size can be passed as a parameter to the map higher order function. So I will use colors dot map and I will say get size. So this, we know that this get size method is called for every function, so called for every element in the collection. First green will be, it will be called with green as the input parameter. So green will be passed here and size of the green will be returned. Similarly, next red will be passed and size of the red will be returned. Next yellow will be passed, then size of the yellow will be returned. Blue, and then the size of the blue. Finally, the whole thing will be collected in a collection and returned as a collection. So we can clearly see that. So this method returned one more collection with the size, here. So we also know that we need not define this function. We know that we need not define the get size method. Get size method, we can directly use underscore is each element of the collection, and on that, and each element is a string. On that string we have a size method. We get the same. We get the same. So I hope the map higher order function was clear. Map higher order function was clear. So the use case is whenever you want to transform your data, you read the data from your file, you want to transform that record, each record to something else, we use the map higher order function. And it's same as the map method of the MapReduce framework in Java. There it is a framework, here it is a language level, we have the capability. Now one more question. I want the first element of each string. We know that colors, I have colors. So I want a collection which gives the first character of each string. First character of each string. So how can I get this? How can I get this? So we know that any string, if I say val x is equal to, if I say Scala, x is a string, and the string value is Scala, and we know that we can say that string is a collection of characters. String is a collection of characters. So how do we access the elements of a collection? We know that this is the way we access the elements of the collection. So we get the first element of the string collection. String is just a collection of characters, which will give the second character. So we can use this method. So we can just say colors dot map. We take each element. This is nothing but string here. Each element is a string. We take each element and we get the first character of that element. So obviously we can say that we can get the character. So any transformation you want, you can do that. So in this transformation, if you see, we transformed a collection of string to a collection of integer. Here we transformed a collection of string to a collection of characters. We can transform to any data type based on your logic. Can we get the substring of a given string? Yes, we can. Yes, we can do that. But that will be for every element. We have to do it for every element. We can assign collection return. Right, right. Usually that's how we do. Usually that's how we do. So I can say like this, right? Val sizes is equal to this. So sizes is nothing but collection of all the this. I can say val first char is equal to colors dot map underscore of 0. So you can write any function there, any function. So I hope the things were clear. And the use case is you want to transform each record from your data to something else. So collection is nothing but a, how we can have a bigger view of a collection. If you see your data may be collection of records. This may be record 1, then we have record 2, then we have record 3, record 4, record 5. Similarly, we have lot of records. Records are nothing but collections. We have a collection of element. Data set is also a collection of records. We take each record and we transform into something. Whenever we want to do a transformation, ETL kind of a transformation, so we use a map hierarchy function. So I hope that was clear. So for we don't use for yield. We don't use for yield. Most of the times we use a map hierarchy function. Instead of using for yield, we use map. So I hope that was clear. So in a similar fashion, we also saw one more for. We also saw one more for. So we saw one more example for expression with iterator guard. This we called as iterator guard and this we called as a yield. For with yield with iterator guard is used to filter out something. I want to filter out, I want the result only the collection which is divisible by 3. I don't want all the, I am filtering out some elements. From the original collection I am filtering out some. So whenever we want to do a error handling, I want to uh, I want to filter the error records from all the records. So that's where we use a for with yield with iterator guards. But I also said that internally it is implemented using a filter function. So that filter is again a filter higher order function on a collection. It is again a filter higher order function. So it takes any collection. It could be a list collection, it could be any collection. And that collection could be of any type. It could be a collection of integer, it could be a collection of string or a character, anything. On that again we have a filter higher order function. That function takes again the same type as the collection type. We have to define a function because it takes input from the collection itself. Hence the data type has to match. And that function returns Boolean. Returns Boolean, and the destination collection is also collection of type A. It does not change because we are not changing the data type. We are not changing the data type. It is the same data type as the collection data type. If you see here, we have a collection from 1 to 20. We are just discarding some elements and keeping some elements. We are not changing anything. We are just discarding few elements. Obviously it will be the same data type as the original data type. If the original collection data type is integer, the destination will also be the integer itself. So that's the reason I'm specifying it is of the type A, same type. But map always used for transformation, hence it could be of any other type. So what does this Boolean mean? So if this function returns true, if this function returns true, that element will be collected in the destination collection. If this function returns false, if this function returns false, element is discarded from the destination collection. So that's the idea. So you can write any function. You can write any function, user defined function, and pass it as a parameter. The only thing is it has to return true or false. That's all. It has to just return true or false. So I can just say in this fashion, I have nums function. I have num function. I can define a simple function, num filter, I will say. I'll just define one function, num filter. Since it's a collection of integer, I have to pass an integer parameter to this function. And I will just say, and just simple condition I will put, if x is greater than 5, if x is greater than 5, return true, else return false, else return false. So this means that I want to collect all the elements which is greater than 5. So you can clearly see that it takes an integer which is the same as the collection type, and it returns a boolean. So obviously I can pass this function as a parameter to our filter higher order function, num filter. So what happens? We know that this num filter is called for every element. First it will be called for 4. Now 4 will be checked whether it is greater than 5. Obviously it is not, hence it returns false. So and what I said here, if it returns false, that element is discarded from the collection. it will not be in the destination collection. It will be discarded. Similarly, next we write 5 will be passed this function. Next, this function will be called for the next element, that is 5. Again, it checks whether x 5 is greater than 5. Obviously 5 is not greater than 5. 5 is actually equal to 5. Again, it will return false. Similarly, 6 and 7, this function will be called with 6 and 7. So 6 and 7 will return true. Hence only 6 and 7 will be stored there. So I mean to say you have your own data set. There you have records, and you want to parse the record and filter out the error records. You want to parse it. Some may be malformed records, some maybe we don't need such records. All those things may be there. You may not have a clean data set. You have to clean it. So if you want to clean it, you can always use the filter higher order function, and you can define your own function based on what type of data it is. If at all it is a JSON data, you can write a JSON parser inside that. If it is a good JSON record, return true. If it is a bad JSON record, return false. Or you can write one more XML function. You can write an XML parser. If your data set is an XML, you can write an XML parser. If it is a good XML record, you will return true. If it is a bad XML record, it will return false. Obviously, good records will be collected and bad records will be discarded. So that's the use of the filter higher order function. Filter higher order function. So we know that we need not define the function. I can just say, we know that underscore is each element from the collection. I can just say underscore greater than 5. So this is also fine. This is a shortcut that we have been seeing from the long time. So this is how we use a filter higher order function. We will be using, when we go to Spark, everywhere we'll be using this map higher order function or foreach higher order function or a filter higher order function. We will be using more and more. That's the reason I'm trying to explain these things here. So I hope that was clear. The filter higher order function was clear. Filter higher order function was clear. In a similar fashion, there is one more function. There is one more function called a reduce function. Reduce function is also a higher order function. It takes actually two parameters. It takes two parameters. Both the parameters are same as the collection. It is same as the collection. And it returns the same type. And finally it returns a type. So if you see the map higher order function and the filter higher order function, both function takes a collection and finally it returns a collection. It takes a collection of type A and it returns a collection of type B, the map higher order function. And how this is transformed? It is transformed by this function, which takes each element of the collection and transform to something else. But if you see the reduce, it's completely different. It takes two parameters from the collection. Consecutive two parameters, I can say. It takes two parameters of the same type as the collection type. And it also returns the same type as the collection type. It also returns the same, this function, the function that we will be passing as a parameter to the reduce. And the reduce itself also returns a type element of the same type. The main difference here is map and filter returns a collection, reduce returns a single element. Reduce returns a single element. So to generalize this, reduce takes a collection and returns an element. It does not return one more collection. It returns a element. So the name itself, the name itself says reduce. Take a collection, reduce it to single element. The name itself says map. The name itself describes everything. Map. Take each element, map it to something else. Something else. Similarly, filter. Take an element, filter it whether it is a good or bad or anything. Similarly, reduce also says the same things. The name itself says that takes a collection, reduce it to a single element. So that's the reduce higher order function. So now what is the use case? What is the use case of a reduce higher order function? So if you see this statement, reduce takes a collection and returns a single element. It takes a collection and reduces it into a single element. So what kind of problems can be solved with this? Takes a collection, return a single element. So what type of problems we can solve? So we can compute sum. We can compute sum. So if you define a method, it is just like go through all the elements of the collection and finally return a single element which is the total of all the elements. We can solve sum here. We can also solve product. Take all the elements of the collection and multiply it. It gives a single element. So whenever you want to compute the product of all the elements in the collection, we can use reduce. Similarly, I can say subtract. I can use subtract. When you want to take all the element of the collection and subtract one by one, so we can use the reduce higher order. Finally, it will receive, you will get a one element. In a similar fashion, I want to compute minimum min element. Obviously, I have to go through all the element of the collection and return a single element, which is the minimum of all the elements. Obviously, I can use the reduce higher order function. In a similar fashion, max. So reduce could be used for solving all these problems. Solving all these problems. So but let's see how it looks like. How it looks like, how we syntactically write it, and how it internally works. All these things we'll see now. All these things we'll see. So I said that we can achieve sum. We can achieve sum using the reduce. Let's try to achieve that. Let's try to achieve that. Then we will see internally how it works. So I can define a function. Define a function total sum. I can define a function total sum which takes integer. If you see, if I should be running it on a nums collection. I will be running it on a nums collection. Nums collection is a collection of integer. It is a collection of integer. Hence our function also should take the same data type as the collection data type. So that's what I have written here. It has to take the same data type as the collection data type. Reduce should take the same data type. I will be running this on top of the nums collection, hence it has to take the same data type as the collection. Then I will say just x plus y. X plus y. So if you see here, it takes two integer and returns an integer. And our collection nums is also integer. Our collection is an integer. The total sum also takes an integer and returns an integer. So I can see that in my reduce, our collection is of type A, function also takes type A and returns type A. So obviously I can pass total sum here to the nums. I can obviously pass total sum method. So let's pass that method. Nums dot reduce, nums dot reduce, pass the total sum. So we can see that 5 plus 4 plus 5 9, 9 plus 9 plus 6 15, 15 plus 7 is 22. So we got that result. We got that result. And also we know that we need not define this function. We need not define this function. Instead of that, what we can do, we need not define this function. I can only directly use the literal of the function. I can directly use the literal of the function. This also will give the same thing. In a similar fashion, I need not specify the input parameters also. Underscore will give the first element, first parameter. Second underscore will give you the second parameter. So we need not specify x plus y also. X is, instead of that I can specify underscore. Underscore means the first parameter. Second underscore means the second parameter. So it will give us the same result. It will give us the same result. So I hope that was clear. I hope that was clear how the, but let's see how internally things work. So internally, let's see what is this x actually, what is this y actually, we need to see. So let's understand it, how it internally works. So what we have val nums is equal to list of what we have 4, 5, 6 and 7. Then what we did, we did something. Nums dot reduce, and I will use the function literal to explain this. So what we had, x comma y, and we said x plus y. This is the function literal that we used, right? So now what is that parameter, to understand? So we also had defined a sum total, which takes int y int, and we defined x plus y. Either we can use a function itself or we can write the function literal also. So now what is x here and what is y here? So x is actually called as the accumulator. X is called as a accumulator. And the accumulator is initialized always to the first element of the collection. X is called accumulator and it is always initialized to the first element of the collection. What is y? Y is nothing but a iterator. Y is nothing but iterator. It will iterate from the second element to the last element of the collection. From the second element to the last element of the collection. That's what we call as a y. X is first parameter is accumulator and the second parameter is the iterator. Then we have this definition of the function. We have the body of the function here. What does it do? It just adds x and y, x and y. After adding this, whatever is returned from this function, whatever is returned from this function, again it is stored back in the accumulator. Hence it is called as accumulator. It accumulates the value. It accumulates the value. So this, after this body is evaluated, whatever value we get, that value is stored back in the accumulator. That's why we call it as a accumulator. So initially what will happen? Initially x will be 4 and y will be 5. X is, or the accumulator is initialized to the first element of the collection. Y will iterate from the second element to the last element. So we got x and y. After doing x plus y, we get 9. 9 will be again stored back in the accumulator, and y will be iterating to the next element. Again these two will be added. The added value is again stored back in the accumulator, and y will be iterating to the next element. Now again x plus y will be added. Again the added value is stored back in the accumulator, which is 22. So this is what happens inside this function, inside the reduce. This logic that I'm speaking about, that is the implementation of this reduce higher order function. Internally these things happen. And finally, accumulator is returned from, accumulator is returned from reduce. So 22 is finally returned. So the return is actually nothing but the accumulator. So this is how the reduce higher order function works. This is how the reduce higher order function works. So I hope that things were clear here. X is called the accumulator. Internally, this is how the reduce works. This is how the reduce works. So if I want to compute min and max, if I want to compute min, how can I do that? With the help of reduce higher order function. With the help of reduce higher order function, if I want to compute min and min, how can I do that? So we have to be aware that it has to take the integer, and it has to take return an integer. The function should also return an integer. So I can define a function, def get min, it takes integer y integer, and here I can say if x greater than y, return x, else return y. Oh, sorry, I'm saying min and I'm returning max. My mistake. If x less than y, I will say. If x is less than y, then return x, else return y. Obviously we can see that it takes two integer and it returns an integer, which matches the data type of the higher order function. So I can just say get I can pass this to the colors. Sorry, not colors, because colors is of type string. Nums dot reduce, and I can say get min. So it will give you the minimum one. In a similar fashion, we know that we don't have to define this function. We don't have to define this function. We can directly use the literal of the function. I can directly use x comma y then I can say if x is greater less than y, I return x, else I return y, else I return y. In a similar fashion, I can use the function literal to get the max, to get the max. If x is greater than y, return x, else return y. I can do that. So this is what we use a reduce higher order function. Reduce higher order function. Now since these are all functions, I can chain these functions all together. A function returns one more. If you see a map higher order function, it takes a collection and returns a collection. And that returned collection, on that I can call some other higher order function like filter higher order function, which takes a collection and returns one more collection. And that collection again, some other function can be called on that higher order function. So what I am trying to say here is I have nums here, I have nums, or let's say we'll take the colors. I have colors higher order function. On colors, I will say val result is equal to on colors, we'll say map. We transform each element of the collection, which is a string, to get the size of the string. So obviously we'll get the size. We'll get the size. It is again a collection. We know that it is again a collection. I will not return it immediately on that collection. I can just call the filter higher order function. And I can say get me all the elements which is greater than 4. We have a collection of integers. I only want to filter this. So I can filter. So I get this. I can change in this fashion. In a similar fashion, I can also, we have a collection. On that collection, I can call the reduce function. I can call the reduce function and I can say add the elements of all the collection and get the sum of the collection. So if you clearly see this is nothing but our map reduce function. This is nothing but our map reduce function. So we can achieve map and reduce kind of a functionality just using these methods. Just using these methods. So we can change such kind of a methods. So there the frameworks took care. Now we were able to achieve the same thing using a language. So why did we talk about these things is so this collection, it could be a list collection, it could be a range collection, it could be an array collection, it could be an array buffer, or it could be a vector, or it could be an RDD also. RDD is also a collection. RDD is a concept in a Spark. So Spark internally is nothing but a collection of records. So RDD is also a collection. So like we have all these methods that we saw which works on a collection, the same methods have been implemented to work on the RDD also. That's what the Spark is. We have to transform the data, we have to reduce, aggregate something, so we use the Spark and we use these kinds of functions in our RDD, in our Spark. So that's the reason we talked about first higher order function, then we talked about collections, then we talked about higher order functions on collections. That's the very important step because the same thing we'll be doing in the Spark also. We'll be doing the same thing in the Spark. We'll be writing the same kind of a function. There will be no difference. Only the collection instead of list, it will be RDD collection. Now one more question arises. So we know that we can achieve all these things. We can achieve all these things with the for loop. And we have seen that also. We can use it, for loop can be used. Map can also, it's nothing but we can use the for loop and solve the map function. In a similar fashion, filter can also be done with the for loop. If we can see the reduce also I can compute the sum. If you see, I can compute the sum using, I can say var sum 0, and I can say for I comes from nums, and I can say total sum plus equal to my mistake. I can say this. So we can say this total sum. So it is added. I can achieve the reduce also by simple for function, for expression. Then why we are using reduce higher order function when we can achieve the same thing with the for loop? Why reduce is being used? Why we are using reduce? We can write a min function also. There actually exists a min and max. If I say nums, if I say nums dot min, I will get the min. There is a method exist. If I say max, it will give a max. Then why do I use a reduce higher order function? When I can achieve the same thing, all these things can also be achieved with the for loop. One second. Just a second. Yeah, sorry for that. That was a call from some delivery. I had to pick it. Amazon delivery. So let's what I was talking about here is, so when we can solve this with the for loop itself, all these functions can be solved with the for loop. This reduce can also be solved with the for loop. So why do we have this reduce method, filter method, map method, and for each method? So what is the intention behind that? Why we are having? What is the intention? Why these methods were designed? What was the purpose of this design? Any guess on that? We can write a for loop and it works fine. But why these extra methods were designed? What was the purpose of these designs? Mm, that is more generic is also fine. These are all right, but there is a one more main important thing is, for loop you cannot parallelize. For loop you cannot parallelize. Meaning, if you have a collection, for loop will start from the first element of the collection and it will loop sequentially one after the other. It will loop sequentially one after the other, and then it will give a result. So which is not good for distributed processing, which is not good for distributed processing. So if you take this map function or filter function, you can parallelize this. If you have a collection, and if that collection could be divided, some some elements, we can have multiple instances of the map function or the filter function or the reduce function which can run in parallel and do the transformations or do the reduction or do the filtering. So the main idea is this: you can run this map on different CPU cores and achieve the same thing. We can parallelize these things. Using this parallelism, we achieve the we achieve the uh, uh, we process the data in a much faster fashion. For loop we cannot. Hence, this is how that functional programming comes into picture. If you have a module by module, function by function, we can chain these operations and we can run in parallel such that we can achieve the data processing much faster. So that's the reason functional programming is much suited for distributed processing, because these functions we can parallelize, and there are these methods has been developed to parallelize your data processing. Parallelize the data processing. Each function can run on a different CPU cores on a different data set, and finally they can aggregate things. So if you see reduce, it can aggregate things. So this is one more use of functional programming and higher order function. If you remember, I said one use case of higher order function is to reduce the number of lines of code. One more use case is you can pass any parallel function to that higher order function and we can achieve the parallelism. So that's the idea so Scala as a language is more suited for that. Now Java 9 also, I think Java 8. Java 8 also has a functional style programming. Up till Java 7 nothing was there. All these for each, this map, this filter, this reduce, function object, function object, function, function literal, all these things are available in Java 8 also now. So don't I'm not saying that Scala is only gearing up, Java is nowhere going. No, Java is also going forward. They are also implementing and going forward. So they will go in parallel. Always they will go in parallel. So that's the idea of the functional programming language and how it is parallelizing, how the methods are defined such that it can be parallelized. So that's the idea. So I hope the things were clear till here. A function has, I'm not sure, a filter, reduce and all are there, but it has function. Lambda expression is nothing but a higher order function. Lambda expression is Python is nothing but higher order function, but I'm not sure whether they have for each, map, filter or reduce. But since Spark has these functions. So and Python can call these functions. In the Python language we can call these functions because these APIs are the Spark APIs. Spark APIs also has these methods and Python can call it. But Python as an independent language, does it have that? That I need to look into. I'm not sure on that. but in Spark it is there because Python is as one more API on the Spark. I hope that that was clear, and I think it's already 9:03. Let's wind up the session here, and let's continue tomorrow same time. Thanks everybody. Have a great day. Thanks, and have a nice day. See you everybody tomorrow same time.